So firstly, I'd just like to thank you for having me. It's my first time in Poland, and I've loved every second of it already. And my first time at Front Trends, obviously, and I've heard so many great things about this conference, and it's one of the most well-organized conferences I've ever been to. So it's a great, great triumph to the team here. So thank you for having me. So I'm here today to talk to you about breaking news at 1,000 milliseconds. Now, what the hell does that mean? Hopefully, by the end of this talk, you might have a better understanding of that. If you haven't guessed it already, I work at The Guardian. It's a UK international newspaper. We now have offices in New York, Australia, and London. And we're expanding, no longer just being a UK newspaper, but becoming an international media organization. I work at the core team at The Guardian, the core web team. It's predominantly on front end there, but a bit of full stack, where I'm helping to make the next generation of The Guardian website. If you haven't heard this already, you can go and visit at next.guardian.com or click on the beta logo at the top of our website. We're completely re-architecting the platform from the ground up. We are not using one bit of code from the old platform. And it's a tough task that's taken us nearly 18 months now, but hopefully we'll be coming to a screen near you soon. Brad Frost once coined the phrase, planting the responsive seed. And that's exactly what we're doing at The Guardian. Like other large organizations like BBC News, it's quite a scary, daunting fact when you tell your product owner that we're going to chuck away all the code and start something from scratch. So we actually decided to do it from a mobile-first approach. I know that buzzword's been coined around a lot today. And so currently, you can see this on your mobile devices up to 7 inches. And we did this, our old platform was outsourced to a third-party company. The platform was so bad that it went down the night of the UK elections. And if you're a media organization, that's a very, very bad thing. And it wasn't acceptable, so we had to do something about it. Last month, in March, we broke quite a big triumph for The Guardian. We hit through 100 million unique users in 1 month, making us one of the largest news platforms in the world. Our current platform just wasn't designed to be able to take this load. So 100 million unique users actually equates to 6,000 different devices, be it an iPhone all the way down to an old Nokia up to desktop ones. That equates to hundreds of user agents. Again, the old platform wasn't designed for this. So here you can see an example of the load time of our old platform. This is obviously slowed down. These are hundreds of milliseconds versus our new one. By the time that our new one has finished rendering, the old one is still constructing its page, and it will just carry on. But let's just see this in real time. What does the user perceive this to be? And we're still waiting, and waiting, and waiting. You can see where this is going. So on average, our current platform takes over 10 seconds to render. This is just not acceptable, especially when nowadays we've got these 6,000 devices. Our users are accessing them from 2G, 3G. Network across the UK and the whole of the world ranges and differs. This is not acceptable to be able to deliver our news in over 10 seconds. On the flip side of that, user load time expectations are decreasing. From 2000, our average, we as users expect them to load in 9 seconds. Now in 2012, your average user expects your website to load in under 2 seconds. I find that astonishing, but I, for one, know that as a user myself, I expect my websites to be fast. But us collectively at web developers, it seems that we're not making our websites to fit that user expectation. HTTParchive.org is a great initiative. You should go and check it out. I ran this test literally 2 days ago to say, hey, HTTP Archive, tell me, out of the top 10,000 websites, what is the average render time? The speed index is what Google uses as an index for the amount of milliseconds it takes for your website to finish rendering. So you'll see that the median average is around 9,000 milliseconds, but the 90 percentile is around 17 seconds. I found this astonishing that still today, out of the top 10,000 websites, we're still rendering in around that 10-second barrier, whereas our users are expecting it faster. So when we started thinking about how we can create a new platform at The Guardian,
we went out and we surveyed 3,000 R users about 17 core product drivers, one of which was speed. And not to my surprise, our users rated speed the second most important factor, only after easy to find content. And you'd hope on a news website that the content is easy to find. And it was the one factor that they said was very important. Ilya Grigorik on the Make the Web Faster team at Google, he's recently written an amazing book called High Performance Browser Networking. In that, there's some HCI research that this actually comes back from Xerox PARC, the guys in San Francisco, that they found that for a machine to be deemed as working by a user, it needs a feedback from an interaction within 1,000 milliseconds. This isn't just to do with websites. This could be me sitting on my sofa at home watching television. I change the channel with my remote. I need cognitive feedback within 1,000 milliseconds. After 10 seconds, my mind, my subconscious will abandon that task and carry on to something else. So you can see now how important it really is that we try and render our pages within 1,000 milliseconds. Now, I know this is hard for us. We saw that we've been, as developers, we've been thinking in seconds. Up to 10 seconds was acceptable. No longer can we do that. We really need to start thinking in milliseconds. So we set out at The Guardian to maybe, what if we could set this as a budget? What if we could say to ourselves, on the new platform, we have a strict rule that our pages, our new features, must render within 1,000 milliseconds. A lot of people have been talking about this concept of a budget recently. Tim Kaldek said that as a performance budget, it's just what it sounds like. You set a budget on your page and do not allow it to exceed that. It could be by the number of requests or the size of the page. Now, I slightly disagree with Tim here that it doesn't really matter about the number of requests. Not all bytes are created equal. An image request is going to be very different to a JSON response. So I found it much easier to set a limit on how fast you render to the screen, that user perception. So we call these budgets at The Guardian our lines in the sand, lines that we're not willing to cross over, and that all new features that we create on the new platform must adhere to these lines. So here they are. And so what I'm here today to talk to you about is it's about a story of performance and progressive enhancement and how we adhere to these lines in the sand on every new feature. So let's dive right in. Your given web page is made up of many components, be it the header, the sharing component on the widget, the image at the top, the footer. But at the end of the day, a user on The Guardian has come to read the news. A friend has shared a link on Twitter. I thought, oh, that's an interesting article. Click. That is the sole purpose of my journey to The Guardian. I've come to read the news, not the social widget in the right-hand corner. So on our existing platform, to be able to construct that page on the server and then send it down the wire, I first had to make a database request for the popular content, for the article content from our content API, and for the comments. All of this happening server-side first before we even push anything down the wire to the user. But what if our comment database went down, which it has done in the past, it's been known to? That meant that actually I can't even construct that page on the server side, and therefore my user would see a 500. That's not acceptable. The user has come to read the news. Yes, comments are obviously very beneficial, but they came here to read the news. So we started thinking about this concept of that we like to call swim laning. How can we isolate that content on the server and deliver that first, and then progressively enhance the rest? We set a rule that we're only allowed to make one blocking database request per HTML file that we serve to the user, and that has to be the content first, nothing else. So in a new world, you see here that we swim laned that content, and only that is delivered in the initial HTML payload, and then we can go and AJAX in the popular content or the comments. But if the comments were to fail, we've now created a system that is resilient against failure. We'll still be able to deliver the news, even though for that instance we don't have comments. So here's it in reality. If you were to download our page, initially that's all you get sent. It's just the article.
afterwards, we progressively enhance each of the new sections afterwards. This creates resilience, and above all else, we can still deliver the news. But as we learned earlier, for a system to feel responsive, we must react within 1,000 milliseconds. But before we do that, we have to have a bit of an understanding of how browsers actually work, how the browser gets from that initial you clicking on a link to rendering on the next screen. First, we have to perform the networking. That on your average mobile connection, that's made up already, we're swallowing up 600 milliseconds just doing the networking itself. This is taken from Google PageSpeed Insights. You can see a 1,000 millisecond budget is now being shrunk down to only 400 milliseconds that we get to play with. And that's your average connection. Some connections on 2Gs, you're not even going to hit that barrier. So you can see how important it is to be able to render as fast as possible. So once we perform the networking, we've got the HTML file, we can start parsing the HTML file. Fortunately, as the spec says, and as browser does, we can parse the HTML incrementally, i.e. we don't have to have the whole of the HTML file before we can start constructing a document object model. So as the bytes come in, packet by packet, we can start creating the DOM. But we have to stop. If we hit a link attribute, a style attribute, or a script element, we have to stop and perform that networking loop again before we can carry on constructing the DOM, for two very important reasons. Firstly, we need to be able to create a CSS object model. This and the DOM together create a render tree. Unfortunately, CSS can't be incrementally parsed because of its cascading nature. If I would start to paint every bit that I've got in, obviously styles later on in in that same file might override those. So by the pure nature of CSS, we have to wait for the file to be fully downloaded before we can construct the object model. But once we do, together we have a render tree. But our wonderful friend and foe, JavaScript. We all love him these days. We used to hate him, but he's now obviously amazing, and he gives us beautiful interactive applications. But when you come to the initial render, he's actually a very, very big enemy of mine. DOM construction cannot proceed until JavaScript is executed, because obviously JavaScript might do a document.write. It might alter the document object model. So we have to stop construction of the DOM because JavaScript might either create new nodes or also existing ones. But JavaScript is tightly coupled to CSS. We can't execute the JavaScript until we've downloaded all the CSS, because JavaScript might query the CSS object model. It might go, hey, what is the style of this element? You can see how intertwined the three of them are. And this is why it's so important, and this is why there's that age-old best practice rule of styles at the top, JavaScript at the bottom. Make your JavaScript asynchronous. Take it off the critical path. And so by saying async or defer attribute on your script element, you're making a contract with the browser, and you're saying, I know this JavaScript is not going to alter the DOM. You can do the networking for it when it is, and free up the critical path to rendering. That's why it's so, so important. It's actually very funny. I ask this in a lot of interview questions when I interview quite a lot of people. And I always ask this question, why do you put JavaScript at the bottom? It's best practice. Why? Why does it block? Why does it block? And a lot of you are surprised how many people don't know the answer to that question. Once we have a render tree, we can finally perform layout, create the geometric shapes for everything, and paint to the screen. So we've got to do all of this in 1,000 milliseconds. So as you'll see here, this is a waterfall. I hope you all know what they are. This is taken from webpagetest.org. It's showing us each individual bit of the networking, the download, and then the key events here that we happened on page, DOM content ready and start render. So your average website is going to look like this, and it's not actually a bad thing. We have to wait for the CSS. Eventually, because we passed that, we can now execute the JavaScript, and eventually we can paint to the screen and our start render. But as we know, we should be asyncing our JavaScript, and instantly that already gives us a much faster start render time. Surely we could do something better than this. We now know how important CSS is to the critical path. In my mind, it is the only thing that should be blocking your critical path, and essentially it is the critical path. But what is your critical CSS? On a responsive website, that age-old concept of above the fold is very tricky. Something that's above the fold on a mobile is not above the fold on a desktop.
you really have to start to question, what is the littlest amount of CSS that I'm happy with to send down the wire that I've got enough information within that first screen? Again, is it your sharing widget or your popular content, your comments, your related content, or the commercial component? It's none of that. It is the article. It's the thing that your user came here for. In my case, they came here to read the news. So we've got this critical CSS. I now know that I only care about that CSS. The rest of it can come later. What if we were to inline that CSS, that critical CSS, into the original payload of the document? Therefore, your browser instantly has enough information to paint. Nothing blocks the critical path. One HTTP request to be able to render the news and break news within 1,000 milliseconds. So you might have guessed it already. It's very controversial, but that's exactly what we started to do at The Guardian. It goes against everything that we've been taught as web developers, as separation of concerns, behavior in JavaScript, your styles in your CSS file. If you go to the web page now and you look at the head, you'll find a large, horrible-looking chunk of inline CSS. But what impact does it have on the user? Visually, how fast are we actually painting? The bottom one is inline, the top one isn't inlined. It's nearly 400 to 500 milliseconds faster because we've inlined and we're taking everything off the critical path. But you may be wondering, so when do we load in the rest of the styles, the stuff in our global CSS file? So at the bottom of the page, we now make an asynchronous request for those styles if we have the JavaScript support for it. If not, we'll just load CSS with a normal link element and it blocks, but that's only for a smaller proportion of our users. So we load the CSS asynchronously, taking it off the critical path, the rest of it, and then we cache it in local storage. Therefore, on the subsequent request, the next time our user comes to the page, back in the head here, we've got our inline, and then we say, hey, have you got the rest of the styles? If so, inject them instantly. Because if we didn't have this, you'd have a flash of unstyled content. You have your critical CSS paint, then later on you async it in, and you've got to paint again, and that's not a desired effect. So leveraging the local storage, we now again have all of the styles within one HTTP request. We use web page tests a lot at The Guardian, so what's the statistical analysis of this? This is beforehand. We're still doing quite a good job. This is from a UK server running a cable internet connection. Afterwards, you see, look at the shape of the waterfall here. And we don't need to wait for the CSS file. We're instantly rendering as soon as the document's been parsed. That shaved off 400 milliseconds of our render time. But more importantly, it's gone beneath our budget. And if you were to look at the site right now, you won't find any style sheets at all loaded in the document. But you have the styles sitting there and a bit of cache invalidation using an MP5 hash of the file. Google and Bing have been using this technique for the last 2 years, but it's only now that more and more, it's actually become more and more commercial companies are using it. So Google do something even more interesting. And as far as I'm concerned, the Google search results page is the fastest web page in the world. And the way they do that is that they send down all of their styles inlined in the head. They then inject it into local storage. They then set a cookie. And then for all subsequent requests, they don't even send down the inline one because they know you've got it primed in your local storage. Unfortunately, we can't do that at The Guardian because we have a stateless, on our new platform, it's also stateless. All of the login is handled with JavaScript. But obviously, this is a hack. We shouldn't be doing this. I like to call this section, what would Tim say? What would Tim Berners-Lee do? HTTP 2, Lisa just mentioned it. As far as I'm concerned, this is the most important change in web technologies that we're going to have within the next 5 years. The first draft of HTTP 1, the underlying transfer protocol of the web, was released in 1997. It's now 2014. We finally got a new spec. But the most important thing when it relates back to this hack is that we allowed concurrent messaging down the same connection. We don't have to incur that 600 millisecond latency overhead on every request. We can send the CSS down the same TCP connection as the HTML. Even more impressive, there's a new feature called server push.
So normally, the browser would have to parse the HTML, hit the link element, and then go, right, I need to go and do the networking for it. With server push on HTTP2, your server can say, right, you've asked for the HTML file, but here's the CSS and the JavaScript, because I know you're going to need them soon. And it all gets sent down. And so this eliminates our hack. So I can't wait for it. Speedy, you can already use Speedy in most browsers now, but the HTTP2 specs are due to be finalized towards the end of this year. As you can see, that we're designing a new system to obviously be resilient to failure. Therefore, every new feature we create must also be resilient to failure and be able to fail gracefully. It is the internet, after all, and networking connection will always drop. This is the story of my life, and I'm sure all of you see this on a daily basis. You sit there waiting for a bloody font file to download just so that you can see the content. Normally, it's just a bit of textual content. You've just come to check something. Oh, when's the bus time? But you're sat there waiting for this. Or I'm on a train. A friend of mine on Twitter says, this is a really interesting article. I click on the article. I've had enough networking to be able to get the HTML file, but then I go into a tunnel. And I'm sat there waiting for the fonts to download. I've already got all the text in the HTML file. Why do I have to wait for this? What does the spec say? The spec is obviously, as all specs is open for interpretation. It says that a user agent may render text transparently with a fallback font, or they may not. That's up to them to choose when to. But if a download fails, a user agent must eventually display text. A great article by a friend of mine, Ian Feather, called Web Fonts and the Critical Path. He did some research into all the different behaviors of browsers and how they handle font loading. IE doesn't very interesting. It doesn't block at all. It will show you the fallback, and then once it's got it, it will repaint on top. Firefox blocks, so you get that nice loading, but eventually, if the request hasn't made after 3 seconds, it will show you the fallback. But WebKit and Blink, they will just hang waiting for the font. So at The Guardian, we didn't think that was acceptable, but we have a bit of an issue here that our typeface is our brand at The Guardian. We spent a lot of money for a lovely typeface by Commercial Type called Guardian Egyptian to be designed for us. It is what makes up the core underlying brand of The Guardian. It's what stands it out when you see the newspaper on a newsstand. You know that's The Guardian because of the font. So when we were delivering the new platform, we were like, we really, really want this. But we also, because of our lines in the sand, we knew that we couldn't allow it to block. Do fonts really have to be a first-class citizen? They must always fail gracefully. So Andy Hume, our client-side architect at the time, he came up with this concept as fonts as progressive enhancement. What if we were to deal with fonts the same way that we do with every other feature? So that's exactly what we did. So first, we do what we call a cut the mustard test. We check to see if we deem this browser a modern browser. Does it have native proper event handling? Does it have a correct XML HTTP object? Does it handle function prototype bind? If not, fine. They're not going to get our JavaScript application anyway, so we'll fall back to the font. If so, do they support a modern MIME type, a correct file type? If not, we'll fall back to the font. Is the font in local storage? Have we already been here? Have we cached it the same way we do with our CSS? Great. Let's go ahead and show it. If not, do we have enough space? We then download a JSON file. Now, this is interesting. We don't download the font file. We download a JSON file that contains 4 different versions of the font. So we can bundle up all of those fonts into one HTTP request, all keyed on the JSON file, represented in base64 encoded strings. So yes, we're making a trade-off here. We're actually we're making the font file heavier, but because we're reducing the amount of requests and making it cacheable in local storage as a string, the positives outweigh the negatives. I'll show you that in a second. We cache in local storage, and then we eventually show. So this is an example of this exact blob of JSON. If you go and look in your local storage on our site, you'll see it. So we've open sourced part of this process. You can go and check that out at Grunt Web Font JSON, made by Andy, as I said. But again, what does the future hold for us? Surely that's another hack. First one is font load event spec, and this is great. We will now have native DOM events that will tell us when the font starts downloading, its progress, and when it's finished downloading. And that allows us as developers to be able to make much more educated decisions as how we want to handle the font rendering for certain elements. And really, really nice bit of this is that they've implemented it with ES6 promises. So it's just some geeky JavaScript bit that I really like the fact that most of the new working drafts specs are all starting to implement promises natively. This gives us a finer control of how we want to load our events. And why should we be stuffing everything in local storage? What is wrong with HTTP cache? Now, HTTP cache on mobile is very unreliable. It's a shared space that you're fighting for with everyone else. So we've resorted to local cache because we find it more reliable. But Service Worker, coming to a desktop near you soon, it's got this whole concept of being offline first. We should be creating features that will work offline regardless of the networking. So it has a cache layer that we can have access to and make decisions as to whether or not we want to revalidate that cache or not. So finally, every request must be measured. Now, it's all well and good making your website extremely fast, but that's always going to slow down. We always need to know. And maybe something that's fast on my MacBook Pro is not fast for my user on a 2G connection somewhere in Europe. So what are our real users seeing in the wild? And to be able to do this, we need to be able to measure everything. The first way we did that in our CSS, as I said, so injecting CSS inline into the head, you don't want to overbloat your HTML file, so you need to keep a strict file size on that. We need to be within the first packet. If you've got a full open window, TCP window, that will be 14K. So we're ensuring that all of our head CSS files stay within 14K. So in the CI, I wrote this tool that I can now monitor the size and trend it over time of knowing exactly how big our JavaScript assets are, our CSS assets are, and then set alerts so I know when one of my developers deploys a change that they've then made slow down our website, essentially. But again, what are the real users seeing? We now have the navigation timing API, so a window on window.performance.timing. Unfortunately, Safari is the elephant in the room here. This allows us to get the exact millisecond timing information for each request made in the browser, and we can beacon that back to a server. So here you see, this is our current new platform, and as you see, we've got DOM content ready. We're definitely rendering on median average of below that 1,000 milliseconds. And now I can know, we deploy up to 4 times a day in The Guardian now, and so I can instantly know if a deploy has slowed down the website. That in comparison to the old platform, which again, as we all know, is loading way over 10 seconds. Real-time is definitely the best type of analysis, but sometimes you need statistical, long-term, synthetic analysis is the word I'm looking for. We use speedcurve.com that is constantly, every day, running 4 tests against our site, and so we can trend over time how these core events are happening and see and compare us against ourselves, our existing platform, and our competitors. And again, I can see and go and ask a developer what happened on the 14th of May. This is exposed, this dashboard exposed throughout the company to all of our product owners, our designers, and all developers. This makes us all accountable for the performance and change. And so the product owner will get an email, weekly email every morning telling them, and they will come and ask us, say, hey, Patrick, what did we do last Wednesday? Why have we slowed down the site? And always, when you're monitoring things, always set alerts. Know when your deploy has broken and when you've broken your performance budget. So what does the future hold for us? There is also nav timing API we've already talked about in RUM, but that only allows you access to the actual the original HTML file. What about all of the third-party requests that you make, all those ads that you're loading in? You have a contractual relationship with them. Why shouldn't they not adhere to our performance budgets as well? So with the resource timing API, they set a header, and that allows the browser to have the security access to see that timing. And then again, you can beacon that back. So I will know when our ad server is starting to slow down, and I can email the right person to say, hey, why have you broken our budget? So with all of this, obviously, we're beaconing all this information back to a server, but that is incurring HTTP requests.
the great guys at W3C have come up on the performance working group, have come up with this idea of the beacon API. So you can say to a browser, hey, I want you to drop this beacon, go off to an image pixel somewhere. Here's the data for it. But it's up to you when you do the networking for this, when you have the resources to be able to do it. It's been great. So that's all of them. So I just wanted to share with you finally some takeaways of some of the things that I've learned along the way and that we've learned at The Guardian building the new platform. Everyone must be involved when it comes to performance. It must be baked into your workflow. It must be a first-class citizen that these discussions are happening in every new feature. You need to be able to share this information with your designers. Why do we have to do this? Why do we do that? It's going to break our budget. Be held accountable for change. Always deliver your core content first. What did the user come here for? They came here to read the news. The extras can come later. And try and set a performance budget. It has worked for us. I hope it works for you. It'll be really interesting to talk to people if you've tried similar things in your organizations. But most importantly, measure, optimize, and repeat this. Your sites will slow down. That's a guarantee. Ours definitely has. That is just the nature of the web. The more things we add, the more things we're going to slow it down. But most importantly, take this away, that performance has to be a requirement. It's not a feature. It's not something that can be retrofitted afterwards, or it's not something I'll leave it to the ops team. It's really our responsibility as front-end developers as much as the server guys to be able to be making fast, optimized pages that render as fast as possible. Thank you. I don't know if I've got time. I've got time for questions. Do I have time for questions? Yeah, a few.
Hello? Okay, so I have a question. Do you know how many of your users, because you said you were going worldwide, not only UK, so how many of your users are not using JavaScript? I know it's a weird question to ask, front-end JavaScript conference, but
yeah, it's a great question. It's
because you thought that you're loading stuff, you're doing lots of logic in JavaScript, so I can imagine that basically you get kind of blank page with only, the critical CSS when the JavaScript is disabled. And the next thing, also related to that kind of, is the SEO. So for your reasons, because often happens that you load shitload of content because it's important for SEO. The elephant in the room. So
to answer your first question, it's below 1% have JavaScript turned off, but our cut the method test reaches about 90% of our users. So about 9% of our users have JavaScript turned on, but we don't deem their browser advanced enough to get our JavaScript application. And they'll just get the content, as long as they get the content. So that links nicely into the SEO question, is that as long as the way that you're progressively enhancing these features, they all have placeholders in the DOM. Each one of them has a link to an actual real resource where you would be able to get that content. So a spider can still access all of our content. It's just that, and most spiders these days are actually executing a JavaScript context as well. So, at the end of you kind of have it. But so yeah, as long as all of your content is accessible, then we haven't seen it have any negative impact on SEO.
Okay, so effectively, when you have the content, you replace the placeholder with the content.
Yeah.
Hi. A few years back, Facebook introduced a thing they called BigPipe. Did you consider using it?
Yeah. BigPipe's really, yeah, we have considered using it. So BigPipe is a technology made by Facebook, for those of you who don't know, and it's how they manage the batching of their CSS and assets. And yeah, I would love to talk to you about that. So yes, we have. There's various reasons why we haven't. Some of you might also know about Google's page speed module for Apache and Nginx. It does a lot of the similar types of optimization of inlining. It does it on the fly. There's two reasons why we don't use it. One, it does it all on the fly, and two, I like to have a lot more of a granular control over what CSS I am inlining. I don't trust a bit of Nginx codes to do the correct, especially when it comes to responsive site. You need to know the exact bits of CSS. But no, we haven't looked into BigPipe, but we're very interested in it.
Patrick, great talk. I was wondering, because I use The Guardian. I like The Guardian. I use it to read the news. And I am wondering, what frameworks are you using to build The Guardian?
So quick introduction to the stack. We previously were a Java house. We've moved to its new, cooler, younger brother, Scala. All of the server infrastructure is written in Scala using the Play framework, so it's just another MVC framework. Play has a Java and Scala flavors. Us, LinkedIn, and Twitter all use the Scala version of the Play MVC framework, so that's on the server side. That talks to our database we have a content API level, so we're just a rendering tier. We don't handle any of the business logic. We have a content API that's open to all of you as developers to use. You can just go to openplatforms.theguardian.com. And then on the client side, we use AMD modules. Everything's AMD loaded through Require. We don't use jQueries. We prefer to use micro libraries. So we use things like Bonzo and Bean and things like that. So small micro libraries to polyfill most of that. But as I said, with cutting the mustard, we choose not to polyfill the types of JavaScript that browsers don't support. We just deem to cut those users out. And on the CSS, we use Sass as our preprocessor.
Okay, so I've got two questions. You have mentioned the flash of the unstyled content before, and you're loading the initial content of the website inline so that it can be styled without any delay. But what about the synchronously loaded modules? Are you dealing with the flash and the unstyled content too, somehow?
So I don't understand what you mean by the sync. We don't have any synchronously loaded modules. Everything is asynchronously loaded apart from the raw content that goes down on the page.
Okay, I get it. Thanks.
Yeah.
Okay, thank you, Patrick.
Thank you very much.